Good afternoon, everyone. My name is Sunil Sadani. I'm part of the product management team at the HPE. And next 45 minutes, we are going to establish something here. How many of you are CCIEs, JNCIEs, and like that? Just raise of hands. Okay, remember when the routing used to be cool? We're going to make in the next 45 minutes routing cool again. So today, in this session, we are going to cover the WAN aspects of it, right? Because today, when people talk about the networking, focus goes on the data center or SD-WAN. How many of you know the difference between SD-WAN and WAN? 1%. That was a joke. So we are going to just focus on the WAN and routing specifically. If you heard the keynotes, Rami said that networks are critical in the AI. Let me tell you the story from this morning. I woke up and I decided that I'm going to count on number of times I hear the word AI. And you know, I was going down the elevator, one floor, I heard 11 times. I said, I cannot count it. Can you guys think how many times you have seen, heard the word AI this morning? Probably 1,000, maybe 2,000. If you walk the booth, probably 10,000 times. Everything is about the AI. So I'm going to cover first couple of things, why routing is important in this AI era. And then I'll give it to my colleague, Tanya, to share some of the cool things which are specific to the HPE routing. Let's take 10 minutes to read this slide. I want all of us to take little thing in the history. Internet, 90s, right? What was in that era? Everyone was trying to connect. It was a dial-up first, then we went into a little bit so-called ISDNs, then DSL, cable, fiber, 1 gig, 100 meg, 10 meg. I'm sure that some of you remember that world. And that's when the Juniper, which is now HPE, was formed, right? Right in that era, a startup was formed in the Silicon Valley called Juniper. And it built the operating system which still lasts today. And I'll share some details why I'm bringing that point up. Then came the so-called the video era, followed by the cloud era, mobility era, right? This was all combined, right? Which year iPhone was launched? What was the year for the iPhone? 2006 or 7. 6 it was launched, 7 it was for the public consumption. So that was the era. This is when Juniper came in with the first silicon which can forward the traffic in the hardware at the layer 3, layer 4 world. And then the cloud started scaling. IoT came. And for the last 4 years, AI has taken over, right? Now, different challenges in each era, right? What is the main challenge in the AI era? Everything is a challenge in the AI era. Whether it's a bandwidth, whether it's scalability, whether it's security, everything is a challenge in AI era. There's no one dimension anymore. I want you to see this slide for 30 seconds. I'll take a silence here. Just look at this slide for 30 seconds. Internalize this slide. I'm not sure whether you've seen the data in this format before, but this was the study we did recently, and the public report just went out today, I believe, right? So you can see the much bigger version of this. How many of you agree with this? Raise of hands. Fifteen more seconds. Numbers are very real. Productivity increased 60 to 70%. Some people say even more, right? But it's very real. the data movement, value creation because of that is huge. I think this is, let's talk about this number, 2.6 T to 4.4. How many of you believe this number? I think this number is wrong. Scott is here from NVIDIA. What is the valuation of NVIDIA? A lot, right? So how the value creation is only 2.4 to 4.4 trillion dollars when the market cap for NVIDIA is bigger than that? And I'm not counting Googles of the world, Microsofts of the world, all these new clouds, and everything else which is coming along with it. So the value creation is very real, right? It's right here. The proof points are here. Now, let's look at the second row. Everyone talks about the AI training. How many have really thought about the AI consumption? Is there a focus in the market about the AI consumption? How the enterprises will use this? We'll answer that questions in upcoming slides. I want to spend 5 minutes on this slide. And I saw a lot of hands raised, people who are CCIEs, JNCIs, and networking experts planning or running the networks. Left-hand side was the world of yesterday, right? What was in the world of yesterday was asymmetric traffic, right? A lot of download, less upload. Go and check your speeds today, now here in this network. Your download might be a gig, upload might be 100 meg, right? How did people reacted to it? See, service provider build the networks in most part of the world, which is oversubscribed network. Your last mile is oversubscribed. You assume that only one user will be active every time out of the 10, or maybe 2. Depending upon which part of the world you are, the oversubscription ratios are different. The other thing is, right, have you seen the network router configurations? 48-port downlink, 4 ports uplink, right? That is how it is. That means you have a lot more downlinks than uplinks. Again, everything was in the back of the mind because of the asymmetric traffic. Now, on the right-hand side of the picture, that is not true in the case of AI era. The traffic patterns are going to be more symmetric. Uplink, downlink will start matching. Because if you have to render a video, you have to upload a video, right? If you have to get intelligence every time a query goes, that's when the inference and everything else comes about it. And we'll talk a little bit later with Scott on this very topic, that what we are trying to do in this era to make sure that when the AI consumption starts happening, and it will happen at a massive scale, what routing has to do to make sure that we are ready for that. Agents don't sleep. Remember I was talking about oversubscription? Peak hours, non-peak hours. Businesses don't work in the evening times. Oversubscribe it. Netflix works in the evening time. Make sure there's appropriate bandwidth for that. People sleep. But who don't sleep? Agents don't sleep. We talk about agentic AI, all this machine learning, automatic cars, all this agent. Even if your electric vehicle today is sitting in your garage, still doing some network activity in the night. So agents don't sleep. That means now you cannot assume that you can take a downtime window at 12 o'clock midnight to upgrade your router or a switch. Can you? I don't think so. Because you have always an activity on the network. You cannot assume these are the peak hours, these are the off hours, let's take a break. These are the modern AI applications. Again, I'll come to the routing. Trust me, another 5 minutes and I'll come to These are all the problems we are talking about, right? We are not talking about the solutions yet. Modern AI applications. Again, I will be preaching to the choir if I go and read all this to you guys. But here's where the kicker is. This is the end user. How many of you run the NOCs or are in the network operations? How many of you use the Mist or Marvis? Few of you? Aruba Central? Okay. I really want you to walk to the demo booth and see the activities it performs all the time, right? That means network is on all the times, communicating to the servers, compute, to the external worlds, all the time. So you don't have to sit and type an email or upload a video or watch the Netflix. Network is always active now. Okay, so what does it mean? What we need to do? First is the quality of traffic. Especially when we talk about the AI training, quality of traffic is very, very important. All this old routing issues, reordering, spraying, load balancing, hashing, all these things, right, has to be super efficient. Service providers have to change their network. As I said, the last mile will look very different. But there's another interesting thing which is happening, right? We can see it, but we are ignoring it. It's the world of neoclouds. World of the providers which provide GPU as a service. Not every enterprise will be able to build their AI clusters, right? That means they have to rely on a third party, for a provider, which is neoclouds or GPU as a service provider. That means now they need to have direct connectivity into that neocloud provider. Even if you're consuming the AI, the chat GPT or whatnot, through a public infra, that also will look very different. That means service provider has to make sure that the last mile they have built in the past, which is oversubscribed last mile, has to change. It starts from there. Enterprise has to change their connectivity. Of course, SD-WAN is here and will always be there. But also now you need to complement that with a direct connection or a WAN connection for the enterprise segment. Also, right, why WAN becomes even more important. You don't have enough power in a building to power a data center. With all that GPUs and compute, everything, right, cannot fit in the building. In fact, it cannot even fit in a city. We are already seeing some location where city power doesn't have a grid even 10 miles apart. That means now your data center, which was in this proximity, has to go 5 miles apart, 10 miles, 20, 100, 200, and 300. But all of this has to talk to each other, right, for seamless experience. You cannot have that, okay, I'm sending this guy to this data center, that guy to that data center. There's one more element to this. When enterprises will consume the AI, right, they cannot just rely on one hyperscaler, one cloud provider, or one service provider. That means they have to have multi-tenancy in their consumption, even if it's their own models. That means WAN will start looking different from that perspective also. And these are the numbers from the study I was talking about. This is the real study, more than 300 big enterprises, medium enterprises across the globe. Most of the enterprises, big size, are already thinking to move from that 1 gig, 10 gig connections to 400 gig connection, bypassing even 100 in some cases. In fact, moving to 800 gig now and bypassing the 400 gig generation because they can see it. They can see what is the impact of the traffic on their WAN infrastructure. Almost everyone we spoke to, whether it's a service provider or whether it's an enterprise customer, financial, starting with the financials, then retail, healthcare, everyone is thinking to re-architect their network in order to meet the AI. They don't want to be left behind in the AI race, right? And of course, as Rami was mentioning this morning, right, People are thinking to cure the diseases using this. This is becoming so important in every aspect of our life. So investment is going in, and it's going now. I'll come back to the stage. Let me invite Tanya now to share, these are the problems, how we are solving that. Tanya?
Okay. Hi, everyone. Audible enough? Okay. I'm Tanya Bhatia. I'm a product manager with the routing infrastructure group at HPE Juniper Networking. I think it was a great view. Thank you so much, Sunil, to see how AI is actually impacting the traffic patterns we all have gotten used to. So think about it. The old methods of caching at the edge, it won't work anymore. AI responses can't be stored up front. Sunil mentioned this. The uplinks are becoming heavier than the downlinks. Your end customers, your employees are not just consuming, they are generating content. And we also touched upon the AI agents that never sleeps. So it's not just about more traffic, it's about a very different class of traffic. And I would like you all to internalize it and think, is your network truly ready for the surge in AI-driven traffic? Because that's where HPE Juniper's routing strengths matter the most. Okay, how many of you know about Juniper's routing portfolio? Okay. Let me tell you something. Juniper is not new to routing. We have been trusted by over 10,000 plus customers globally in some of the most demanding WAN environments, be it a financial institution, bank, stock exchanges, a government backbone, or a research and education network. And these deployments have not been by chance. It's because of decades of engineering focus on routing. While some vendors have taken a fragmented approach to routing, Juniper has maintained their story. Optimized silicon, purpose-built platforms, and software innovation. And it's that consistency because of which we have shipped over 200,000 plus routers, and we are present in 100% of the Fortune 500 companies. Okay, so even before the acquisition happened, HP had a very strong portfolio. You all are aware of it. We have our GreenLake for hybrid cloud. We have Aruba for campus and branch. But there was one critical layer missing, the routing layer. It's the layer that basically connects these different domains and makes it look like one integrated system. And with Juniper now part of HPE, that gap is bridged. You get the full portfolio end to end. But why is routing so important, right? It's basically the layer that connects your public infrastructure, it connects your colo facility, your cloud environment, your own campus and branch. It's what makes it talk to each other seamlessly and looks like one integrated system. And for you all, HP partners and customers, this is the value. One network, one vendor, one experience, basically one neck to choke. Okay? So that was about how AI is impacting the traffic, what this acquisition means for you. Now let's come to the actual meat, right? What is our routing portfolio? Okay, for decades, Juniper has followed 3 basic principles to build their portfolio. Automation. Automation for us is built in our product design, whether it's programmability, telemetry, intent enforcement, or lifecycle orchestration. Performance. Line rate throughput is non-negotiable, whether it's 1 gig port or a 800 gig port. Whether you are turning on the security features, creating new VPNs, evolving your services, the expectation from our routers is to provide line rate throughput. No compromise. Sustainability. And I think a lot of you would agree, routing assets are long-term infrastructure assets. If you put in a router in a government backbone or a service provider core, the expectation is it needs to sit there for at least 10 years, if not 15 or more than that. And that kind of longevity comes from deliberate design choices. Thermal headroom, modular software, power efficiency, hardware architecture that is programmable when a new protocol comes up, right? And with these three principles in mind, Juniper has designed every layer of their routing portfolio. The silicon, giving you the right silicon for the right use case, whether it's deep buffering you're looking for, high service logical scale you're looking for, power efficiency, we give you the right silicon. Systems. System is basically the platform you deploy, and it needs to go in sync with the silicon. Because you might be designing the best silicon, but if your platform is not able to take the heat of it, it's not optimized. And finally, the software. It's basically what drives your hardware, giving you a seamless operational and automation experience. OK, before I get into our silicon strategy, let me ask you all a few questions. I hope it's OK. How many of you have 1 gig links in your network? OK? How many of you have 100 gig links in your network? OK. How many of you have started thinking about 800 gig links in your network? OK. First of all, thank you so much for answering. And the variety of responses is going to help me justify this slide. Because we cater to very different set of customers, right? With very different motivations, very different requirements. Cloud customers, they are at the cutting edge of technology. They are the first ones to adopt any new protocol that comes up. When we launched our first 800 gig router, a cloud customer was the first one to get it in their hands. Service providers, for them, the network is their business. They sell connectivity. They sell VPNs. For them, it's all about ROI, return on investment. And finally, our enterprise customers, they want simplicity and security. They want things that work. But the challenge is you can't optimize all the requirements of the customers in one silicon. Some vendors have taken that approach. They are investing in a single silicon that, yes, helps them save some engineering resources, but they end up with a compromise. Either the scale suffers, the power efficiency goes away, or the flexibility drops. Juniper took a different approach. We triple invested in our silicon because we understand giving you the right silicon for the right use case is important. Our first silicon, Trio chipset. This is Juniper's homegrown ASIC based on a run-to-completion architecture. Basically, it's extremely programmable, extremely flexible, perfect for scenarios where you need a high service and logical scale. Second, Express Silicon. Juniper's homegrown ASIC based on a pipeline architecture, basically perfect for scenarios where you're looking for high throughput and power efficiency. Juniper was the first one to start this category of ASICs. And finally, we have also invested on a portfolio built on merchant silicon. We have a Broadcom DNX chipset-based portfolio optimized for low port speeds, perfect for your metro networks, access, and aggregation boxes. And these three silicon basically serve as your underlying layer of three product families. OK, let me start with MX. How many of you have heard about MX? OK. When I joined Juniper 5 years back, and you are supposed to do these product trainings, how I was introduced to MX, I was told the brand loyalty of MX is incredible. I think everyone loves MX. All those who raise their hands, I'm sure you would have similar stories to tell. And it's because of a reason. MX is what we call as a do-anything router. Basically, it can take up any routing use case. If MX can't do it, probably there is no other platform in the planet that can do that use case. And it's across customers, be it enterprise, service provider, or a cloud. It is perfect for your backbone, your peering router, your border edge router, DCI, and now increasingly with the AI edge, MX is finding the perfect fit. The PTX series. This is our powerhouse of hyperscaler and high throughput environments. When we launched PTX, the AI era did not even exist. But as AI came into picture, our design philosophy behind PTX proved spot on. Because you need fast, efficient, high throughput links between your data centers, where PTX serves as the perfect fit. And finally, we have the ACX. ACX is our optimized router, I would say. It's built on Broadcom's DNX chipset. It has a wide variety from 100 gig all the way to 4.8 terabit, optimized for scale, optimized for throughput, optimized for power efficiency. And we also have hardened boxes perfect for your outdoor deployments in your utilities, your roadside cabinets. So that will be the ACX series. But pick up any router, ACX, MX, or PTX, it all runs on Junos. Junos has 20 years of software innovation behind it. Unlike some vendors who bring up a new OS when a new product family comes up, Juniper has maintained Junos for 20 years. It has been battle tested across every routing use case. It has seen it all. Sunil showed us the different eras. Junos has seen it all, be it the 4G, 5G era, cloud era, now the AI era. It's been that common thread that has enabled all of these. OK, let's take off the mask. And this is our portfolio, right? And you can see we give you all different form factors, fixed form factors for simplicity, modular chassis for scalability. We have 100 gig optimized platforms. We have petabyte optimized platforms for your high throughput environments. We give you redundant control plane. We give you hardened boxes for your outdoor deployments, right? In fact, it also includes MX301 that Rami talked about today, and we launched. We, in fact, launched it today, our new generation 400 gig optimized router, 1.6 terabit in capacity, integrated IPsec, MACsec, and it has all the routing features you need. And it is virtually, it can take up any routing use case, perfect for you all who are looking for a 400 gig optimized box for your aggregation and edge layer, right? OK, so that was about our portfolio. Let me just spend a few minutes to talk about our automation strategy. I think I don't need to explain you all what intent-based automation is, right? You might be hearing about this from every other vendor. It's easy to define intent. What is tricky is to preserve that intent when there is so much going on in your network, right? For example, you have a lot of routing domains in your network, a lot of multi-vendor routers, evolving SLAs. When a trading feed hits in the network, it's expected to have a less than 15 microsecond of latency. An ATM transaction is expected to have 99.9% accuracy. How do you maintain those SLAs with so much changes in your network? That's where Juniper's routing director comes in. It's not just a provisioning tool. It's an intent orchestration and assurance engine. It takes your intent, converts it into service placements, picks the PE routers, applies the VLAN IDs, and pushes the configs. It also continuously streams telemetry, applies the AI knowledge to make sure your SLAs are being preserved. We, in fact, have a dedicated session tomorrow on our automation and AI ops strategy. If you're interested, I would highly recommend you all to attend that. Finally, on sustainability, right? And I mentioned these are the pillars we design our portfolio on. For us, it's not just a feature, it's a design principle. And now with the AI inference explosion, it's expected that the power consumption is going to double in the next 4 to 5 years. So for a lot of you who think sustainability is not what I'm interested in, you will have to look at it to make sure you manage your OpEx, to make sure you have enough power and cooling for your networks, and also to obviously meet your corporate sustainability requirements. For us, sustainability is at every layer. Be it a silicon, we have the latest technologies with thinner process nodes and technologies like clock gating. At the system level, we make sure we avoid any discrete components like PHYs and retimers and gearboxes that just add on to complexity and power. And finally, at the software layer, our Junos is capable of programmatically turning off idle ports and in some cases instances of ASIC as well. That leads to almost hundreds of watts of saving per node, right? So sustainability for us is not just a feature, it's a design principle. Okay. So that was about our routing portfolio. I will invite Sunil back on the stage to show you some real-life examples of what we are doing.
Thanks, Tanya. Can we get this back? OK. Thanks. Good job. I was listening to Tanya. I remember two things. A customer from this morning told me, I could not believe it. He says he wants to send me a snapshot where MX is up and running for 11 years and 39 days. That's what I think I remember, 39 or 38 days. It's not been rebooted in 11 years. I said, you might have some good power grid or the backup systems to keep on running for that much time. But I've heard the 4 or 5 year stories from a lot of you. A lot of you, the MX keeps on running on that 4 or 5 years. Another thing I was thinking, when was the SRv6 invented, developed, right? SRv6. Which year? SRv6, 2019? What year is this card? 2018, 2019? MX, which was shipped in 2011, can do SRv6. MX is the series which was introduced early 2000s, right? And has been consistently, the chassis we shipped in 2007, we are still building the new line cards for it. That's sustainability, 20 years in the network. Now, it's bad for business, by the way. I don't like that business because I want to refresh it like others do. I want to keep on selling new chassis, new models, new hardware, right? Constantly. But that's not how the DNA of Juniper works, right? Even the next generation MX, which is MX10K, works on the same chipset. So that means the command which works on this will work on the next generation also. Juniper is the only company when the new MX product comes out, day 0, it is 100% parity with the previous generation. There's never been an exception on it. 100% parity. And we continue that in the AI generation as we go along because there's a lot more new things coming. Not in terms of the protocols and so on, but there's a lot of fine tuning which needs to happen in the network, right? So let me take a couple of examples here. First one is this education network Scenic. We might think that why small enterprises will need all this bandwidth, all this flexibility, all this routing, but here's a perfect example of it. A customer called Scenic, which used our PTX and MX series routers, right, to upgrade their network because education is taking a big part in AI, or AI is doing a lot of things for education. And this doesn't come for free. That means all this knowledge which has to be connected between the universities, between the different sectors, what is happening in the medical college, what is happening in the hospital, they all has to connect. And that requires a lot of bandwidth. So don't assume that only big guys are going to need this change. Every place, every location will need this change. Right now, as I said, not everyone will build AI cluster. They will use neoclouds or other providers to help them. I also say this to a lot of service provider friends, right? Anybody here from the service provider? Any? Most of enterprise? Anyway, I'm going to tell this in any case. I tell to service provider, this is your chance, what you missed in the cloud era or over the top era, you can get it back, that mozo back, and start looking into this inferencing, start looking at the last mile build-outs to take advantage of it, monetize this, right? Otherwise, we'll be back in the same stage over the top, we'll do it. They are doing it already. It's already there. And at least I know that one person listened to me, and that is Dave Watt from Lumen. Now, he did not listen to me, he already had a plan. Lumen is building the last miles, is a provider in the US, building the last mile specifically for the AI consumption. Completely new last mile. They're going to the neocloud providers, they said, okay, we'll connect the enterprises to you. Let us provide you the connectivity. We'll be the glue between you and the enterprises. And this is the DC use case, right? Data center edge use case, which is a direct on-ramp use case where MX is used because of its flexibility, the scale. What is the routing scale of MX? A lot of you guys use MX. What is the routing scale of MX? Can anybody tell what is the routing scale of MX? I can't either. It can be infinite, right? I don't think we define the scale of this thing. It can take 10, 12 million we have tested with the VPNs. We never needed more than 3, 4, to be honest, in real networks. So we don't worry about the routing scale. And by the way, PTX, which Tanya was talking about, has the similar amount of routing scale, right? It can go up to 4 million. It's not that we compromise on the scale elements of it. ACL scale, route scale is same between MX and PTX. Yeah, MX might be more, but nobody goes to that level. So with that, I want to invite Scott from NVIDIA to talk about something interesting what we announced today. Scott, please give him a round of applause. Welcome, Scott. Thanks, Scott, for being here. Yep. You want to introduce yourself? No. Oh, sorry. Here you go. You're a rock star. We give wireless mic to you.
Yeah, Scott Sneddon, I lead AI networking segment sales for NVIDIA. NVIDIA is a networking provider. We're really focused on AI Factory and building the network elements needed inside the AI Factory. We speak so friendly because I did spend 11 years of my career with Juniper, and so we all go way back.
Otherwise, you would have not been friendly, Scott?
Well, I would have been friendly in the form of a paycheck. Now we're great partners. NVIDIA's got a long-standing partnership with HPE, and so now we're excited to have Juniper part of this partnership family, and we're working together on some really interesting use cases.
Scott has been modest. He has a lot of experience in data centers. He was Juniper. Now he's running the entire sales for the data center and the networking for the data center for NVIDIA. So, Scott, let me start with this. What is this all noise about this morning Juniper and HPE made that we are partners with NVIDIA? What is this all about?
Well, yeah, so, like Tanya said before, in the routing space, you need different components to provide different functions. There's a reason why Juniper has 3 different silicon platforms in their routing stack. Each of them provides a very specific function in a different way. The same thing exists for AI factories and the connectivity in the AI factory. Whether it's InfiniBand or Ethernet, that's sort of a separate conversation. In reality, off-the-shelf networking and standard Ethernet networks that you'd build a traditional data center with are not necessarily the right thing for an AI factory. It's a very unique use case with extreme demands on bandwidth, but even more importantly, extreme demands on how we load balance and manage congestion on that bandwidth. And so we build and optimize network services to connect inside the AI factory. Now, this is a factory that's taking in raw materials and producing goods. An AI factory is taking in power and data and producing tokens, the thing that is an output of an AI factory. But like in a traditional industrial factory, I might have a whole bunch of stuff in that factory that move goods around. Right? I'm going to bring in something from probably a railroad, and within that factory, I'm going to have an assembly line and some elements that move those goods through the process as I produce my end result. And then at the end of that assembly line, I'm probably going to hand off to a railroad to take that good to the end user. And even if I'm thinking of like BMW or a very large industrial company, they're going to have a factory that might span many, many buildings across the campus, and they might have a very special railroad inside that campus that moves goods from one assembly line to the next. And then they're going to leverage a different kind of railroad that's optimized for distance to take those goods from that factory cluster to another factory. And so there's a need for different kinds of railroads and different kinds of movements of good in this factory. The same is true in an AI factory. I'm moving data and I'm moving tokens between GPUs. I'm training a model, or if I'm doing disaggregated distributed inferencing, I'm passing KV cache and context between GPUs. We build very optimized network services to do that within the factory. Factories might span multiple buildings within a metro area, tens, maybe up to 100 kilometers at the most. We're going to keep that very optimized network thing for that GPU to GPU traffic, but it's also very important that we complement that with technology like Juniper's routing portfolio to connect multiple factories together, to connect the users and the on-ramp and the data that might live at a public cloud into that factory, and then to deliver those tokens out to those users to a more distributed inferencing platform. Lots of use cases where very optimized high-performance routing is necessary in addition to what we build inside the factory.
Thanks, Scott. So just to add, right, as you know, the HPE already has the NVL racks, which is built on the NVIDIA GPU platforms, and our compute platforms are already there, right? Now, in that stack, what is missing, right? The WAN connectivity was missing. That is the stack we are adding to that rack, literally speaking. Now you have long distances interconnectivity between the data centers, right, where you can connect this AI, what we call it AI grid, right, the AI factories together, right, and make it look like one across the board. You touched upon this, and I also talked about it, right, bringing customer, right? Can you talk something about it, why you think that is a critical element, the DCE, what we call it, data center edge, and MX platform, right, we discussed about it. Why MX, right? Maybe if I can ask that. You know MX.
Yeah, I mean, it all comes down to being able to effectively deliver those packets. It's a bidirectional problem. Lots of bandwidth in. There's always been a lot of bandwidth out, but now we have a lot of bandwidth coming in. So connecting those users, oftentimes connecting that data. If I'm doing a RAG optimized AI model for an enterprise, that data might live in a large data source that's in a different data center. I mean, the real problem with deploying, the real challenge, I shouldn't say problem, the biggest challenge in deploying GPUs is power availability. And so you as an enterprise might be thinking, I'm going to stand up a couple of racks of GPU servers, I'm going to talk to my HPE rep, and I'm going to get the latest RTX Pro Blackwell. But the power density you have in that rack in your existing data center might not be enough. And you might have to put those GPUs at a colo provider. But all of your data is still living in your data center. So this on-ramp is all about connecting all of those things, whether it be users coming in or whether it be data coming in and out of that AI factory.
Thanks, Scott. Okay, I'll repeat the question which Tanya asked. How many of you are the MX users? And how many of you have used MX users here? 4, 5. How many have you used the ChatGPT? Everyone? You are MX users, because probably if you're using a ChatGPT, you're probably going over the MX network. I can pretty much guarantee it. 90% of the on-ramps today with the hyperscalers is on that MX platform. Because of its flexibility, because of its capabilities, because of its security, it has an inline, line rate, IPsec, MACsec built into the chipset itself. And also flexibility from 1 gig to 400 gig and everything in between, and going to 800 gig very soon.
And the silicon that we build to create AI factory networks inside is not optimized for that. We're not doing IPsec on those chips. We're moving RDMA traffic, and that's it.
It's very complementary. So what we have announced today is a complementary solution with Spectrum, along with the DCI and the DC Edge from the HPE side of the house. It's a perfect blend to build a mega, giga AI factories.
Yep.
Okay, what next, Scott?
Well, we continue to see scale grow. We continue to see requirements around power optimization. So the green position that we talked about is very key. Like I said, power is usually the currency that's the most challenging to come by. We're doing a lot in NVIDIA around silicon photonics and co-packaged optics also. Rami touched on a couple of those things today. So optimizing the power footprint of the data center networking piece. What you guys are doing on the WAN, again, is a very important consideration. So,
yeah, especially this part of the world, you guys know the cost of the power, pre-COVID and post-COVID. I don't have to tell you guys. That's super important for us to make sure that we maintain that, right, power per bit efficiency at every level. Why don't you take a pause and ask any questions for Scott or me or Rania here, right? Let's go to the Q&A before I conclude this. Any questions? Do we think that routing is cool?
Routing was always.
I want a little noise, right? Is routing cool? Is routing cool? Awesome. No questions, right? I'll just say one thing. We have end-to-end portfolio, partnership with NVIDIA and others.
Yep.
Whether anything from client to cloud, whether you are a mobility device in the end, connecting to Wi-Fi, going into the local area network, going into the wide area network, going between the data centers, or going to the satellites, doesn't matter. We have everything in between in our portfolio. And you can expect the same level of longevity, sustainability, which has been the Juniper's tradition for many, many years. Thanks a lot for your time, guys. Really appreciate you coming here. Join the other breakout sessions too.